All right, welcome. This is video 1 for Unit 8 for AP Environmental Science. This unit is aquatic and terrestrial pollution. Looking at the topics coming up, we're going to be having about 15 videos. I might join some of those videos just because some of the topics are pretty short. A lot of this is review, or not a lot of it, but a good amount of it is review. But we're going to be looking at sources of pollution, human impacts on ecosystems, endocrine disruptors, human impacts on wetlands and mangroves, eutrophication, thermal pollution, persistent organic pollutants or POPs, bioaccumulation and biomagnification, solid waste disposal, waste reduction methods, sewage treatment, lethal dose 50 or LD50, dose response curve, pollution in human health, and pathogens and infectious diseases. So this video is going to be the first part of this unit for Unit 8.1, sources of pollution. So remember to think about waste as a system. Systems have inputs and outputs. So as far as inputs coming into an ecological system, you have plants, living matter, roots, water, and energy from the sun. As far as outputs go, for human systems, we include all of those, and then we also introduce synthetic materials that we manufacture. But as far as outputs go, there's waste. There's really nothing else when we're talking about an output coming out of the system. The issue here, of course, is that waste looks different depending on where it comes from. So from the natural world, this is waste, but this will break down. Is it really waste when we think about it in terms of human waste? Is this waste? Gross. But is it? It will eventually be reincorporated into the environment, into the ecosystem. Is this waste? So you get an idea of really what things we might think of as waste, but in reality, when we're talking about waste in this unit, we're talking about material outputs from a system that are not useful or consumed. This is waste. Humans are the only ones that can produce what we would consider actual waste in our time frame. Now, there's two main sources of pollution. We have point sources. Point sources are really nice because you know exactly where it comes from. They're produced from a single identifiable location. The reason they're nice is because typically if you have a point source of pollution, it's easier to mitigate or stop. With non-point sources, you're looking at more diffuse and broadly defined areas where it is harder to find the direct source because there are many sources that eventually work their way into, for this example, into the river. Now we're also looking at noise pollution. We learned a little bit about noise pollution in our last unit. The reason noise pollution is coming up again is because we're talking about aquatic pollution, and noise pollution can come from ships and subs which have sonar, and that can actually interfere with marine mammals' communication. We'll talk a little bit about the Clean Water Act of 1972, which protects surface waters. We watched a video in class about the water in the Ganges in India, and that's an example to show you of where there is not as much regulation on clean water. But essentially, the Clean Water Act set up acceptable levels of pollutants and allows the EPA to issue permits to those who can directly pollute and how they pollute. So if you look at this graph, it's really interesting to see the number of impaired waterways by state. As you guys can see here, luckily for us, Nevada, we're right in here, not super high up. We also don't have that much that many water sources. The Clean Water Act essentially sets water quality standards. They then can assess water quality. The EPA mandates this to happen. Then they issue discharge permits and they enforce the permit limits. So if you remember when we went to the wastewater treatment plant, they talked a lot about the permits that they have, and they are monitored and regulated, and they have to have, a lot of strict rules on what they're allowed to release back into the environment, in particular in the Truckee River. As far as the history of the Safe Drinking Water Act, this is different than the Clean Water Act. The Safe Drinking Water Act is all about water that we drink, right? So the Safe Drinking Water Act was put in place as one of those things that happened in the 70s with a lot of environmental regulations and legislation that went into place. In 1986, they added more contaminants. Lead solder in plumbing was actually restricted. In 1996, they had mandatory consumer confidence reports that were distributed annually to let people know it's basically what's in the water you're drinking. In 2011, fairly recently, Congress passed the Reduction of Lead in Drinking Water Act, which was effective in 2014. And in 2015, the Drinking Water Protection Act required Congress to submit a strategic plan for assessing risks associated with algae toxins in water. So you can see that the Safe Drinking Water Act has been continuing to be refined and adjusted. It sets that maximum contaminant levels for 77 different elements, but it is subject to political pressures. So there are many things that can happen with the way that it is enforced based on the political pressures that exist. And fracking has actually been excluded from the Safe Drinking Water Act, even though, as we'll talk later, the fracking has an impact in drinking water. So that is the end of our first video for Unit 8. Our next video is going to be human impacts on aquatic ecosystems.